In this video, we will be going through the study guide for the VSEPR quiz and also discussing the quiz format. This quiz will be active on Kia on Friday, 3/27 from 7 a.m. to 7 p.m. Alright, so first our study guide. You will need to complete each of the following tasks or answer questions on each of the following topics. 1. Draw Lewis dot diagrams and 3D sketches. 2. Identify each of the following four-year Lewis dot diagrams and 3D sketches: bonding directions, lone pairs, electron geometry, molecular geometry, bond angle, and whether it is a polar or nonpolar molecule. Now for number 1 and 2, these are very similar to what you had to do in the 3D Molecular Models Lab and the VSEPR practice assignment, which was posted to Google Classroom. But instead of filling in a chart, you're going to be asked each question individually in a multiple choice format. This will be similar to what you are going to be completing on the practice quiz on Kia. Now in addition to this, you are also going to be asked questions about the following topics. How does the bond angle change as you replace bonds with lone pairs? So for an example of this, if you had something like CH4 versus NH3, both of these have a total of 4 electron groups. So I have the 4 bonds and no lone pairs, 3 bonds and 1 lone pair. So they both fall within the same family. They're tetrahedral family, and they have bond angles of approximately 109.5 degrees. But as I replace bonds with lone pairs, the bond angle is going to decrease slightly. So these bonds are going to be pushed closer together because this lone pair is held more tightly to the central atom as opposed to if it was within a bond. Now you do not have to know the exact angle that this would go down to. It would actually go down to 107, but you should know that the bond angle will decrease. You will also have to compare and contrast London dispersion forces, dipole interactions, and hydrogen bonding. This was from the last day of notes that we had in class together. London dispersion forces are present within all molecules. They are the weakest of the intermolecular forces. So whether something is polar or nonpolar, everything is going to have London dispersion forces. These are caused by a temporary dipole, which is based on the random assortment of or placement of electrons within a molecule. So if you consider this methane molecule right here, this would be a nonpolar molecule. At any given moment in time, maybe more of the electrons are on the left side as opposed to the right side of the molecule. That would result in one end being partially negative and one end being partially positive. Now because this only lasts for a fraction of a second, it's temporary, it's very weak compared to the other intermolecular forces that you'll encounter. Dipole interactions are present within anything which is a polar molecule. It means that you have 2 poles. An example of this could be something like H2S. So within this molecule, you have a permanent dipole. You have one end which is partially negative. You have the lone pairs up here, plus sulfur is more electronegative than hydrogen, so these electrons are pulled closer to the sulfur. So this end of the molecule is going to be partially negative, and this end of the molecule is going to be partially positive. In terms of how strong dipole interactions are, it's somewhere between London dispersion forces and hydrogen bonding. Hydrogen bonding is the strongest. It's essentially a more extreme and a stronger version of what we had here with dipole interactions. Hydrogen bonding only occurs when you have a couple of special combinations, so H to N, H to O, or H to F. So hydrogen has to be bonding to an extremely electronegative element, and it only works for these 3. You also have to have a lone pair of electrons. So this is going to be the strongest type of intermolecular forces. For more information on any of these, you can go back to that notes video if you missed any of that from class. You are also going to be asked questions about sigma versus pi bonding and identifying the hybridization for different types of molecules. Now, we did not cover either of these 2 topics within class. They are within the notes video that you were assigned during one of our flexible learning days. So if you did not already watch that video, please make sure that you go back and watch that. Just some general basics here. A sigma bond is the result of direct overlap of orbitals. It is stronger than a pi bond. If you have a double or a triple bond, that extra bond which is made, it's called a pi bond. Pi bonds are weaker than the original sigma bond. For the hybridization, this is essentially how your molecules are able to make these types of shapes. The s and p orbitals that you're familiar with from back in Unit 4 with quantum theory, they are going to hybridize or mix together in order to make these new special hybrid orbitals which are better suited for bonding. Essentially, what this type of question would look like, I might give you something like CH4, and I might ask you what type of hybridization would be required. Now, since there are 4 bonding directions here, that means that you would need a total of 4 orbitals. The easiest way to figure this out, if you add the 1s orbital plus the 3p orbitals, that would be a total of 4 orbitals. So if you have 4 electron groups going around your central atom like you would here or here, because 1, 2, 3, 4, then you would have sp3 hybridization. If you had something like our carbonate anion, which we've drawn in class, where you have 3 electron groups going around the central atom, that would be sp2 hybridization, because you have the 1s and the 2p for a total of 3 electron groups. If you have sp hybridization, that could be something like carbon dioxide. We have these 2 electron groups on either side of the carbon, so that means that I'm going to need 2 orbitals in order to make that happen. Finally, here we have resonance structures. So you're going to be asked questions about resonance structures. An example that we did in class together would be ozone. So remember, for a resonance structure, we had an arrow going back and forth between the multiple possibilities. So on this example, we had our double bond on the left side. I could also draw another example of this, where the double bond would be on the right side. So this right here would be considered a resonance structure. If I wanted a more accurate representation of a resonance structure, since we now know the bond length for a double versus a single bond, double bonds are always shorter, single bonds are longer. When we measure the bond length of something like ozone, we can see that it's not lopsided. It's actually even on either side, and the bond length is somewhere between a single and a double. So a more accurate representation of this would be something where you have a partial bond on either side. So you're basically splitting up that double bond in either direction. Alright, so now some information about the actual format for the quiz. So the quiz is essentially going to be broken up into 2 parts. In part 1, you're going to open the PDF titled VSEPR Quiz Scrapwork for Flexible Learning, posted to Google Classroom. You can either print this out and write directly on it, or you can simply look off of it on your computer screen and then write out your work on a separate sheet of paper. You should also have out a periodic table and your molecular geometry summary papers when you're doing this. I'll have PDFs of those posted to Google Classroom just in case you lost your paper copy. This is the part of the quiz where you're going to be drawing your 5 Lewis dot diagrams and then 5 3D sketches. They're going to be very similar to the ones that you had to do in either the lab or the VSEPR practice assignment from Classroom. The diagrams and sketches are not going to be graded, so your total score is only going to come from the questions that are actually on Kia. But if you do these diagrams incorrectly, you're going to have a really hard time answering those questions on Kia correctly. So please make sure that you are confident in these diagrams, you're sure that they are correct before you move on to the Kia portion. Part 2 is going to be completed on Kia. So after you have all of your dot diagrams and 3D sketches, you're going to open the quiz on Kia. There's no secret word, there's no time limit, and you will be able to save your progress in case you cannot complete it all in one setting. So I know that I had said that there might be some kind of time limit on there, or that I would eliminate the save for later button. I changed my mind. I decided to leave those the way that they're going to be here. But you will only have one attempt. Do not let your session become abandoned. So if you accidentally leave your quiz open for a really long period of time, and then the session just expires, you will not be able to get back in. If you accidentally exit out of the tab for any reason while it's still open, it's going to become abandoned and you won't be able to get back in. So it's very important that you are careful with your assignment once it is open. Just like when you take quizzes and tests in class, Kia is not going to provide you with any kind of feedback after you submit, so you're not going to know your score until I actually post it to real time. And I'm not going to post any grades until the testing window has closed. And of course, I mentioned before, the testing window is going to be from 7 a.m. to 7 p.m. On this part of the quiz, so the portion on Kia, you're going to answer 30 multiple choice questions related to what you would normally fill in for the data table. Now, this might look like it's a lot of questions, but they're all going to be, what is the electron pair geometry? Or what is the molecular geometry? Things that would normally only take you 1 or 2 seconds to answer when you're filling it into the data table. So don't let the number of questions here intimidate you. The molecule on your VSEPR scrapwork paper and also within Kia are going to be color-coded. And I made sure that the colors matched up, so that should help you to make sure that you're on the correct question as you're filling things in. Once you get past through all the stuff that would have normally been within the data table, you're going to have 8 multiple choice questions regarding other details from the notes. So basically what I went through on the previous slide. You are also going to have 2 questions that are multiple select. Now remember, if a question is multiple select in Kia, instead of the selection box being circular, it's going to be a square. So if you see a square there where you can click multiple options, make sure you're reading through all of those and you select multiple answers if it is necessary. Your quiz is going to be worth a total of 50 points, just like all of the other quizzes that we have taken so far this year. Alright, so both the VSEPR scrapwork and the actual quiz on Kia are going to be posted at 7 a.m. on Friday, and you're going to have until 7 p.m. that night to submit it. If your quiz is still active by 7 p.m., it's going to be automatically submitted at that time. So please make sure that you give yourself plenty of time and you don't save it for the last minute. Alright, for how your score is going to be reflected in real time. If you receive a score on the VSEPR quiz which is higher than your marking period 3 average, then your quiz score is going to be entered into real time like it normally would be. Depending on how big of a gap there is between your score and the marking period 3 grade, you should see some kind of increase within your overall grade. If you receive a score on the VSEPR quiz which is lower than your current marking period 3 average, your quiz score within real time is going to be overridden, and it's going to be replaced with your marking period 3 average. This means that your marking period 3 average will not change. In this instance, I will leave a comment in real time with your actual score so you can see what you had. What this basically means is that this quiz cannot possibly hurt your grade. It can only potentially raise it or leave it exactly where it is right now. The quiz will be open within that 12-hour window to work in, so make sure that you are able to take your time so that you can perform well. Alright, if you have any questions or concerns, please feel free to use the weekly mailbag that I posted to Google Classroom. I just posted a new one for today. Or if your question is more personal and you don't want it to be out within that open forum, please feel free to send me an email.